In this demo, we will see how to migrate containerized application WordPress from GCP OKD cluster to AWS OKD cluster and set up DR using RackWare SWIFT. Let's first look at the source and the destination environments and the application that we will be migrating. This is the list of VMs for the GCP OKD cluster. This cluster is deployed in the US East 1 region. Let's access the OpenShift console for this cluster. In cluster details, we can see the OpenShift version of the cluster is 4.8. We have a project WordPress where the WordPress application is deployed. If we look at the workloads, we have a deployment WordPress, which is the front end of the application, and a stateful set WordPress MariaDB, which is the backend. If we look at the persistent volume claims, we have two PVCs, and the storage class is standard, which is the standard GCP persistent storage. During replication, Swift will list the available storage classes for target volumes and convert volumes to the selected storage. In this demo, we will be converting these volumes to elastic block storage. Let's access the application through the load balancer service. So this is the application that we will be migrating, and this is the sample post created. Let's look at the target environment. This is the list of the VMs for the AWS OKD cluster. This cluster is deployed in the Sydney region. Let's access the OpenShift console. Here we can see the OpenShift version of the cluster is 4.8, and we have created a project WordPress, and in this project we have created a secret named RackWare try-secret. The RackWare try-secret has the credentials to access the try image, which is present in the private registry. Try basically stands for transient RackWare agent image. This image is packaged as a part of the Swift product. During migration, Swift will run try instance as a combination of pod and service under the source and the destination namespace for staging purpose. Now let's access the Swift dashboard. You can access the Swift dashboard at this URL, that is IP address of the machine where Swift is installed /swift/dashboard endpoint. During Swift installation, you will be asked to set the initial password for the admin user, and we will be using those credentials for logging in. If you want more information about the Swift operations, you can download the operations guide from here and refer to it. For now, let's log in as the admin user. As we haven't discovered any cluster yet, we landed on the cluster administration page. So before the migration operation, we need to discover both source and the target cluster. So let's add them one by one. Let's discover the source cluster first. I have entered the friendly name as GCP OKD production and selected the cloud type as Google GCP and enter the cloud details. Let's add the cluster. Similarly, let's discover the AWS OKD cluster. I have entered the friendly name as AWS OKD DR and selected the cloud type as Amazon AWS and entered the cloud details. Let's add the cluster. Now we have both the clusters discovered. If we expand this, we can see the summary of the cluster here. We can even list the projects from the cluster. We search WordPress. We can see the pods from the WordPress project. If we select persistent volume claim, we can see the PVCs from the project. For setting up the DR, we need to create a storage pool. So let's create it. Let's add the friendly name as backup pool. Select a device. Click on create. So we have created a storage pool. We can see the details here. So let's create a DR policy now. Let's add the policy name as 30 minutes policy. Here we can create three types of policies: pass through, which is for the migration, and stage 1 is for the backup, and stage 1+2 is for the DR purpose. Here we can specify the periodicity, as we want our sync operation to execute every 30 minutes. So we'll select by frequency and select the minutes as 30. And we want our stage 2 to execute after the stage 1, so we'll select this option. We can add an email address to get the DR alerts. Let's create. Now we have created a DR policy. You can directly apply this DR policy by specifying the sync options, but the recommended way is to perform a migration operation and then apply the DR policy to the migration sync jobs. So let's create the stage 1 and stage 2 sync jobs. Let's select sync type as stage 1. Select the GCP OKD production as the source cluster name. Select the project, which will be WordPress. For applications, you can either select or selective. If you want to migrate all applications from namespace to the target, you can select all. Or if you want if your namespace consists of multiple applications and you want to migrate a few of them, then you can select selective. Let's select all for now. The next set of options are the tripod ports. So you need to specify the ports for the tripod. You can auto select ports if you have this range whitelisted from cloud firewalls, else you can specify ports. This is the name of the image and the image pool secret, which we have created earlier in the namespace. Let's provide a job name, initial stage 1. Let's add the image group name, which will be WordPress backup. Let's add the stage 1 job. Now the stage 1 job has started. Let's wait for completion of the job. Now the stage 1 job is completed. Let's add a stage 2 job. Select sync type as stage 2. Select the image group, which will be WordPress backup. Select the target cluster, which will be AWS OKD DR. Select the project, which will be WordPress. Here we can see the available storage classes for the target volumes. Let's keep it the default one, which is the elastic block storage. Enter the tripod ports. Let's add a job name. In advanced options, you can provide the customizations, like you can apply pre and post YAMLs to the target. You can run pre and post scripts. You can specify CPU and memory requests and limits for the tripod at target. If you want your application to use the images from different registry as that of the source, then you can specify the mapping here. Similarly, you can specify the mapping for the pool secret. Here you can provide the service type mapping, where you can change the type of the service. You can provide node port mapping, where you can change the node port of the service. You can specify specific one or randomize. In volume sync config, you can include specific list of volumes or exclude specific list of volumes from sync. Let's stick to general options and add the stage 2 job. Let's wait for the stage 2 job to complete. Now stage 2 job is completed. Here we can look at the object sync statistics and the data sync statistics. We can look at the detailed checkpoints here. Now let's look at the target cluster's web console. Let's try to access the application. As we can access the application, we successfully migrated the WordPress application. We can even look at the sample post. So now let's do some changes at the source application. Let's add a new post here. Let's add the title as delta sync. So we have now two posts here at the source application. Now let's apply the DR policy to the sync jobs. As we want our policy to execute immediately, we will select start immediately, and let's add the stage 1 job and the stage 2 job. Let's add the fallback configuration. Let's apply the policy. As the policy is applied, we can see the stage 1 job getting executed soon. Now the stage 1 job is triggered. Let's wait till it finishes. The stage 1 job got completed. Now the stage 2 job is triggered. Let's wait till it finishes. Now the sync job is completed. Let's access the target application. Here we can see the new post, which is the delta sync. Now let's access the DR policy. If there is any disaster at your production site, then you can simply fail over the policy using this button. During this, Swift will identify if there are any outstanding changes that haven't been transferred to the target. If this is the case, then Swift will transfer those. If there are no any outstanding changes, then it will simply change the status to failed over. Let's fail over the policy in the drill mode, which is the test mode. This will simply change the state of the policy to drill failed over. Now, if you want to make the production site active again, then you can fall back the policy. click on fallback. As in our case, we had failed over the policy in test mode. This will simply change the state of the policy to fallen back. But in case of a real failover, Swift will sync the local backup to the production site.